Welcome, everyone. Today we're going to clearly understand one of the most important foundations of AWS networking, VPC, and how everything inside AWS securely connects, communicates, and stays isolated. This lecture will help you understand how real production AWS networks are designed step by step. Today, we will discuss these topics: AWS VPC, Virtual Private Cloud, Subnets and Routing, Security Groups and NACLs, NAT Gateway and Internet Access, Production VPC Design. AWS VPC, Amazon Virtual Private Cloud, is an isolated private network inside AWS where you can launch and manage resources securely. You control IP address ranges using CIDR blocks, create subnets, and define routing rules. A VPC can span multiple availability zones for high availability. Public subnets allow internet access through an internet gateway, while private subnets have no direct internet access. This setup is commonly used for databases, caches, and internal services that must stay protected inside the network. Subnets and routing. Subnets divide a VPC into smaller network segments across availability zones. Public subnets use a route table that sends internet traffic to an internet gateway, while private subnets route traffic through a NAT gateway for outbound access only. Each subnet belongs to one availability zone, and route tables control how traffic flows between internal resources and the internet. This structure ensures databases and internal services stay in private subnets while only necessary components are exposed publicly. Security groups and NACLs. Security groups act as stateful virtual firewalls attached to AWS resources like EC2, Lambda, and RDS. They control inbound and outbound traffic and can reference other security groups instead of IP addresses for secure communication. Network ACLs operate at the subnet level and are stateless, meaning rules must be defined separately for inbound and outbound traffic. Security groups are the primary layer used for securing communication between services inside a VPC. NAT Gateway and Internet Access. A NAT Gateway allows resources in private subnets to access the internet for outbound traffic only, while still blocking inbound connections. It is placed in a public subnet and uses an elastic IP for translation. NAT gateways are required for private workloads to access external APIs or AWS services. However, VPC endpoints provide a cost-efficient alternative by allowing private access to AWS services like S3 and DynamoDB without using the Internet or NAT gateway. Production VPC Design. A production VPC is designed with multiple layers: public subnets for load balancers and NAT gateways, private subnets for application workloads, and database subnets for RDS and other storage services. It spans multiple availability zones for high availability. NAT gateways are deployed per availability zone to avoid cross-zone traffic costs. Databases are fully isolated in private subnets with no internet access. VPC flow logs are enabled to monitor and audit all network traffic for security and troubleshooting purposes. Conclusion. To conclude, Amazon Virtual Private Cloud is the foundation of secure and scalable AWS architecture. It allows you to build isolated networks, control IP ranges, and manage traffic flow between resources. Subnets and routing define how communication happens inside and outside the network, while security groups and NACLs provide layered security. NAT Gateway enables controlled internet access for private resources, and production VPC design ensures high availability, security, and proper segmentation across multiple availability zones. Thank you for watching.